Hi everybody. Today our focus is going to be on inequalities, but before we do that, we're going to start by going over some things that we've already done. Except we're going to do them backwards. So instead of having the function and find out with the parts, now you're going to start with the parts and write the function. So we have to write a function with a hole at x equals 1. Well, if x equals 1 is the answer, then our factor would be x minus 1. In order to make it a whole, that factor has to be on the top and the bottom. Now, in order to make this not turn into, something that just canceled and we have f of x equals 1, you need something else. You need to add it to the numerator. So it'd be nice if we ended up with a line. A lot of times when we cancel factors, it ends up with a line. So to do that, we're going to write anything that's a linear expression. So anything that looks like a line. And a line, of course, is mx plus b. We don't want the y equals part because it's already on the outside of f of x. So we could call that x plus 5. You could do that 2x minus 7. However fancy you want to get, it doesn't really matter. I'm going to go with x minus 3. This would be absolutely optional, and not optional, but it's your choice as to how you would write that. So now we're going to write an equation that has vertical asymptotes at positive and negative 2. Vertical asymptotes come from the denominator. So x minus 2, x plus 2. And we have a horizontal asymptote at negative 3 for y equals. Now you know that we end up with a number. It always ends up like this, so the x's would cancel. So we have to make that happen. Well, currently in the denominator we have x squared. So we need x squared in the numerator, so it would cancel. And then we need a negative 3. You're more than welcome to leave it like that. That would work. You could add something else to that if you wanted, or leave it the way it is. I'm going to leave it the way it is. So now we have left-sided and right-sided end behavior. As we've talked about before, we've got a lot of ends. But very specifically, it says left and right side behavior around the vertical asymptotes. The vertical asymptotes are the ones that run up and down. And you can't really tell on this graph because it's a picture from the calculator, so it's just like the calculator, hard to tell. We have a vertical asymptote at x equals negative 2 and a vertical asymptote at x equals positive 2. So we are going to talk about these four ends. I know it says left and right side behavior, but they mean as you approach the vertical asymptote from the left and as you approach the vertical asymptote from the right. So let's just pick one. Let's just pick positive 2. So as x approaches positive 2 from the right and as x approaches positive 2 from the left, we're going to write down what's happening with our ends that are pointing up and down. So positive 2 from the right is over here, coming at positive 2 from the right-hand side. We end up going to positive infinity. This is a y. Sorry, it looks like a 4. Then we're going to do positive 2 as we come at it from the left. That's just this little piece right here. So that looks like it's going towards negative infinity. Then we have the other asymptote. X is approaching negative 2 from the right. X is approaching negative 2 from the left. And we're going to write down what y is doing. So let's take a look at this. So negative 2 from the right, coming at negative 2 from over here. You can see that's this end right here, so it is going up. And then our last end, the one we haven't talked about, is pointing down to negative infinity. Now, rational inequalities. We have done inequalities that were factoring, but these rational basically means we've got some fractions. The rules are the same. You're going to set your function equal to 0. You're going to have to solve it, which means we cross multiply because it's a fraction. You take your answers, you put them on a number line, you write your answer in interval notation. So it feels very much the same as how we've done this before. However, we have one new glitch right here. Holes do not go on the number line. So we want zeros and vertical asymptotes. So we already can find all these things. It's just a matter of putting it together. So let's get rid of this inequality. And when we cross multiply, you end up just setting the top equal to 0. So x squared minus 2x minus 15 equals 0. Basically, the bottom gets multiplied and it gets turned into 0. So it's no longer there. So we're going to factor this. So we have two numbers that multiply to get you 15, 5 and 3, negative 5 and positive 3. So we get x equals 5, and we get x equals negative 3. These are real answers to the problem. These are your x-intercepts, which makes sense on the line, on the number line. These are points on the number line. Now we have some places where x is not allowed to be. If you think about what a vertical asymptote does, that's a discontinuity. So your vertical asymptote is x minus 4 is not allowed to equal 0. We can't have an answer that's going to put a 0 in the bottom of the fraction. So then we get x, I'm going to put it down here because this is an answer, x cannot equal 4. That has to go on the number line also. Now our number line is going to get a little tricky. Small to large, negative 3, 4, 5. Not allowed to equal 4. So this gets an open circle because it's not allowed to equal it. It doesn't have anything to do with the original sign. So it's not allowed to equal 4. So that's an open circle. And then the other symbol comes from up here, which has a line under it. So these will get colored in. The rest is exactly the same. Pick an interval to test. I'm going to test x equals 0. Plug it into the original. The original. So we have 0 minus 15 over 0 minus 4. And is that less than or equal to 0? Well, this is 15/4, which is positive, so this is a no. So here we have an answer in this section, answer here, and no answer here. So interval notation, negative infinity to negative 3. Union 4 to infinity. Oops, sorry, 4 to 5. I wrote down 5, but I said infinity. It is a 5. So to run through this again, super quick, a little bit faster. Cross multiply, which is essentially, okay, numerator rather equals 0. Pretty simple here. We just get x equals 1. Now your denominator is not allowed to equal 0. So here we get x squared is not allowed to be 9. So x is not allowed to be positive and negative 3. All of these numbers go on the number line. Negative 3, positive 1, positive 3. The symbols, it's allowed to equal 1, but the symbol for the 1 comes from the original. So this is an open circle. This is always going to be open from your asymptotes, or asymptote if you only have one. Pick a section to test. I'm going to test where 0 lives. Here's x equals 0. Plug it back into the original. 0 minus 1 over 0 minus 9. Is that greater than 0? So 1/9 is greater than 0, so this is a yes. So it goes no, yes, no, yes. So in interval notation, negative 3 to 1, union 3 to infinity, all with brackets and not squared off brackets. All right, real quick, again, a graph. Wouldn't want a day to go by where we didn't graph something. So let's, of course, the order is find the whole first. Well, it's already factored. So we have a whole, and they put it way down here. I'm looking down here. Whole at x equals negative 2. It's last because it's kind of in the order that we're going to graph it. So that's why it's down there at the bottom, so we don't forget about it. Here, I'm going to do this so we really don't forget about it. Hopefully that will help. So our vertical asymptotes now, again, we don't care about the plus 2. It is gone. So we have our vertical asymptote at x equals negative 3 and at x equals 1. I'm going to put these on the graph. Negative 3 and 1. Horizontal asymptote, it's not multiplied out, but it looks like x over x squared if we don't multiply out all of it. So when there's a bigger power in the bottom, we're at y equals 0. Now I'm not really sure what to do with this, so I'm not going to put it in the middle just yet, just in case it ignores that vertical asymptote or that horizontal asymptote there. X-intercept, take the numerator, set that equal to 0. Well, that was fast. X equals 0. So I guess it does cross. Then we're going to have our y-intercept. When we go back to, well, we don't have it multiplied out, but that's okay. We can put zeros in there for x. So we get y equals 0. Why do I have -2? That doesn't make any sense. So we have y equals 0 over, doesn't matter, 0's on top. We're going to end up with 3 times a -1 on the bottom. I just want to make sure it wasn't 0 over 0. Not that it would matter. This tells us we do have a y-intercept. We already knew that right there. Now we don't really know how to draw the graph without the calculator. So this is kind of an issue. So I'm going to pick a number just to see what's happening. I'm going to pick 2. I can't pick 1. So I'm going to pick x equals 2. X equals 2. I'm testing this area up in here as if it looks like it's going to go there. So then we would have y equals 2 over 2 plus 5. Oops, that's a 3. 2 plus 3 over 2 minus 1. So we get 2 over 5 times 1. So it's positive 2/5. So at 2, we're at 2/5. So that tells you that we're up here. The graph lives up here. Which means it probably also lives, well, I guess we ought to test it. So we're going to test -4. So x equals -4. Plug that into our reduced, so we get -4 over, putting the -4 in there for the 3, -1. And -4 minus 1 is -5. So we get 4 over, or -4 over a positive 5, so -4/5. So that does work. So we're down here at -4/5, so it does fit here. Now the middle is tricky. I mean, you can probably guess how it goes, but we don't really know which way it breaks. So I'm going to try x equals -1, just to see if it's positive or negative. So we get -1 over 2 times -2. It's positive, so we get positive 1/4. So positive 1/4 means it's here, so we can graph this like this. Then we have a hole in the graph. At x equals -2, there's really a hole in the graph. So wherever you drew this to be -2, put a hole right there. And that's our graph. Now that we've drawn the graph, they want us to use the graph. So I'm going to make this a little bit smaller. To do the left and right sided behavior around the vertical asymptotes. Well, we know our vertical asymptotes are x equals -3 and x equals 1. So we're going to do x approaches -3 from the right, x approaches -3 from the left. So I would suggest setting these up and then looking at your graph. So I'm over here at -3. So -3 from the left is going down. So this is -infinity. And -3 from the right is going up. So that's positive infinity. Other asymptote, x approaches 1 from the right. X approaches 1 from the left. So 1 from the right, positive infinity. 1 from the left, this side, negative infinity.